Section 2.5 is solving equations involving absolute value. An absolute value is the distance from zero on a number line. There is no such thing as negative distance, so the absolute value is always positive. For example, absolute value of 3 is 3. Absolute value of negative 3 is also 3. Here's a number line. You had to move 3 places to get to negative 3. And you had to also move 3 places to get to positive 3. That's why the absolute value is always positive. If we're going to evaluate inside an absolute value, we treat the absolute value as if it was a grouping symbol. So we want to work inside the absolute value first. So here we're going to plug in 4 for m. So that's 4 plus 6 minus 14, absolute value. So inside the absolute value, 4 plus 6 is 10. Now once you get the absolute value to one number, then you take the absolute value of it. Absolute value of 10 is 10, and you bring everything else down. And 10 minus 14 is a negative 4. Example 1b, we're going to plug in 2 into the absolute value. So I'm going to bring down the 23 and the minus. Absolute value of 3 minus 4 times 2, close the absolute value. Inside the absolute value, I'm going to do the order of operations. Order of operations says I multiply first. So that's 3 minus 8. So that's 23 minus, inside the absolute value, positive 3 and a negative 8 is a negative 5. Again, bring down the 23 minus, absolute value of negative 5 is 5. So now that becomes 23 minus 5, which is 18. Example 1c, we're going to plug in negative 3 for b and c for 2. So that's 2, absolute value, 2 times negative 3 minus 8 times 2, close the absolute value and bring down the minus 2. Now again, we have to work inside the absolute value. Everything outside the absolute value we just keep bringing. Inside the absolute value, I'm going to multiply 2 times a negative 3, and that's a negative 6. And then that's negative 8 times 2 is a negative 16. Close the absolute value and just keep bringing down the minus 2. Now inside the absolute value, negative 6 and a negative 16 is a negative 2. Excuse me, a negative 22. Now I'm going to take the absolute value of negative 22. The absolute value of negative 22 is a positive 22. And then I am going to replace the absolute value with a dot because I am multiplying 2 times the absolute value. And I just keep bringing down the minus 2. Order of operations says I multiply 2 times 22 is 44, minus 2 is 42. You might want to try to work this problem a second time to make sure you understand it. Absolute value of x is 4. Now we're going to go backwards. We're going to find what could be inside that absolute value. Well, it could be a positive 4, or it could be a negative 4. Because absolute value of 4 is 4, and absolute value of negative 4 is also 4. So there are two values that x could be when we have a variable inside the absolute value. So basically this sets up a little formula. If you have absolute value of x is equal to a, you take the x out of the absolute value and put it equal to a positive a, use the word or, take x again out of the absolute value, and this time put it to a negative a. example 2, solve each equation, then graph the solution. We're not going to graph. Okay, so we have absolute value of f plus 5. Absolute value of f plus 5 is 17. We take it, what's inside the absolute value, we must take out of the absolute value, put it equal to a positive 17, or take it out of the absolute value and put it to a negative 17. Now we have two equations, so we're going to get two answers. We solve each equation, subtract 5, and we get f is equal to 12. Or, over here, subtract 5. Negative 17 and negative 5. My signs are the same, so I'm going to add and get a negative 22. Okay, let me check real quick for you. Absolute value of f plus 5 is equal to 17. If you plugged in 12, you would get 12 plus 5. Absolute value, 12 plus 5 is 17. Absolute value of 17 is 17. Now if you plugged in a 22, negative 22 plus 5 is a negative 17. Absolute value negative 17 is 17. So there are two separate answers for the absolute value, and you must do both of them. Look at example B. Absolute value of b minus 1 is equal to a negative 3. Now, earlier we talked about the absolute value as the distance from 0, and there is no such thing as negative distance. So if you ever have an absolute value that is equal to a negative number, you can stop right there. Say no solution, because an absolute value can never be negative. Example 2c. Absolute value of 3n minus 4 is equal to a negative 1. That's a negative. Therefore, we cannot do anything. No solution. Example 2d. Absolute value of x plus 2 is equal to 4. That we can do. We take it out of the absolute value. X plus 2 is equal to 4. Or, take it out of the absolute value. X plus 2 is equal to a negative 4. Now we have two different scenarios. We're going to get two answers. Subtract 2 on both sides. X is equal to 2. Over here, subtract 2. X is equal to negative 6. So x can either be 2 or it can be negative 6. Either one, when you plug it in, the absolute value, you will get 4. Example 2e, solve. Absolute value of 4x minus 8 is equal to 20. Let me tell you what not to do. Do not start solving inside the absolute value. That is an illegal move. Do not do that. You will get points taken off if you do. You must rewrite it, taking it out of the absolute value. Use the word or. Must take it out of the absolute value again, and this time put it to a negative 20. You will get two answers. Add 8 to both sides. So that's 4x is equal to 28. Divide by 4. X is equal to 7. Over on the other side, add 8. Negative 20 and a positive 8. My signs are different. I'm going to subtract and get a negative 12. Divide by 4. And I get x is equal to a negative 3. So there are your two answers. Example 4a. write an equation involving the absolute value. Now, this is going to be going backwards. You have a dot at 11 and a dot at 19, and we have to come up with an absolute value, an equation. Pick what number is right smack in the middle of 11 and 19. And it's 15, because there's 1, 2, 3, 4 on the right, 1, 2, 3, 4 on the left. So it's going to be absolute value of x, and it's always going to be the opposite of the middle of the center. It's positive 15, so it's going to be the opposite, so it's x minus 15 is equal to, and how many places did you have to go from the center? From 15, we had to go 1, 2, 3, 4 to get to the 19, and 1, 2, 3, 4 to get to the 11. So the absolute value of x minus 15 is equal to 4. How could you check to make sure this is the right answer? Solve it. Take it out of the absolute value. X minus 15 is equal to 4. Or take it out of the absolute value. X minus 15 is equal to a negative 4. Add 15 to both sides. X is equal to 19. Add 15 on both sides. X is equal to 11. And there are the two answers, 11 and 19. So that's how you can check. Now this is the answer. This is the equation. This down here is checking. Example 4b, write an equation involving the absolute value for the graph. Again, we have a point at 17 and a point at 27. So what is right smack in the middle? Looks like it's 22. So it is absolute value. Remember, it's the opposite. So that's absolute value of x minus 22 is equal to, now how many places did we move again? 1, 2, 3, 4, 5. We moved 5 places. That is the equation. Here's the checking again. Solve it. X minus 22 is equal to 5, or x minus 22 is equal to negative 5. Add 22. So x is equal to 27. Add 22. And x is equal to 17. Example 4c, write an equation. So again, we have to find what's in the middle. -2. So it's absolute value. Remember, it's the opposite. So it will be absolute value of x plus 2 is equal to, how many places did we have to move? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. We had to move 6 places. Again, I'm going to check. X plus 2 is equal to 6. Or x plus 2 is equal to negative 6. Subtract 2. So x is equal to 4. Subtract 2 on this side. And x is equal to a negative 8. And that is the answer. So this is my answer. This is checking. And that is the end of section 2.5, absolute value.